Hello. We'll wait until 5, and then we'll start. Hello. So it's 5, and we'll start now. Okay. So hello, everybody. So today we're going to talk about permutation and combination. So we'll start with an example. So how many 6-digit numbers with distinct digits can we make using the digits 1, 2, 3, 4, 5, and 6? So basically what this means is that let's say you have the number 2, 1, 4, 3, 6, 5. So this would be a possible number, and you can mix up the order of these numbers however you want. And then we're asking how many possible ways can we how many possible numbers can be formed this way. So I'll give you guys like a minute or two to think about this. Okay. So here I'll give a hint. So let's say we simplify the situation first. So let's say we simplify the situation first, where you only have 3 digits, just 1, 2, and 3. Then we can just try out all of the numbers and write down all of them. So there's 6 possible numbers if there's only 3 digits. So that's a hint. I'll give you guys a bit more time to think about this. So here for the I'm replying to chats right now. So you can we can draw a tree here. So let's say this was 1, 2, and 3. And then this goes down. And here's 2, 3, 1, 3, and then 1, 2. This would be 3, 2, 3, 1, 2, and 1. And also, it would be preferred if you would chat to Alex, because I'm drawing these things on the board, and it's kind of difficult to take care of everything. So this is a tree that represents every number. So this number here would be 1, 2, 3. So 1, 2, 3, 1, 3, 2, and so on. Until this one, you get to 3, 2, 1. So I think it's been a while. I'll explain how you might do this. So for the first digit, so if you have a 6-digit number, there's, well, 6 digits. So for the first one, there's 6 possible choices: 1, 2, 3, 4, 5, or 6. For the second digit, we can't choose the digit. Let's say we already chose one here. We can't choose 1 anymore. So then there would be 5 possible choices. Let's say we chose 2 here. Then for the next digit, we can't choose 1 or 2. So we have 4 choices. So in the end, we get 6 times 5 times 4 times 3 times 2 times 1 times 1. And this is denoted by 6 factorial, or 6 with the exclamation mark. And if you do the math here, you'll get that this is 720. So this factorial, let's say you have the number 5 factorial. That would mean 5 times 4 times 3 times 2 times 1. So next problem. So that was just the basic example of permutations. So what if now we're going to change the question? How many 5-digit numbers with distinct digits can we make using how many 5-digit numbers with distinct digits can we make using 1, 2, 3, 4, 5, or 6? So I'll give you guys like a minute to think about this. And it's very similar to the previous example, but you should think about how when it only has 5 digits, how it affects it. So the previous example was a special case of permutation, and we're slowly getting to the more general formula, which I'll show you soon. Okay, so I've given a bit of time, and Grace, would you be willing to share how you got your answer of 720?
I'm just gonna annotate. It's kind of bad. So Basically, we have. So I like to think of it as like there are 5 like places, 5 like digits you can use. So basically, this one there are 6 options, like numbers to choose from, and then if we're not going to use that number again, then you have 5 options less, 1 option less, so it's 5, and then this one would be 4, and then 3, and then 2, and then you just multiply it together. I'm on a computer, so I'm kind of bad. Which is basically the same as the 6 digit, just it doesn't have like the 1, because if you have no digit, then it would be the last digit that you hadn't used. And this like last time is 720.
Yeah, very good. So that's exactly how you would do it. So you would figure out how many cases each digit has and then multiply them together. So very good. So there would be 720 cases here, as Grace said. So now we're going to generalize this question. So how many m-digit numbers with distinct digits can we make using the digits 1 through n? Okay. So for the first digit, we would have n possible choices. For next, we had n minus 1, right? Now this goes so on until you get to the last one. And because this is an m-digit number, in total, there's m of these digits here. So using some math, you can find out that this is n minus m plus 1 possible choices.
What if the n minus m plus 1 is negative? What if the m is like way
n is usually bigger than m,
no.
right? Because here you have from 1 to 6. Is 6 minus 5, it would be 1, and then plus 1 is the 2 here. So when we multiply these together, we would get this equation. Now this is actually the same thing as n factorial over n minus m factorial. So just revisit again, factorial is, so like n factorial is the same thing as n times n minus 1 times n minus 2, and so on until you get to times 2 times 1, and then that's n factorial. So if you do the math here, n factorial is n all the way to 1. N minus n factorial is if you start at n minus 1, all of the numbers here until you get to 1 here. So if you divide n factorial by n minus m factorial, all of the numbers that are less than or equal to n minus 1 will be reduced. So then this number here would be n minus m, then plus 1. So that's the formula for permutations. So you can memorize this if you want. Okay, so next we'll go on to combinations. So combinations are a different topic that you also use a lot in combinatorics or counting. So here's an example. If there are 100 games I can choose to play from, and I want to play 2 today without order, so you can choose A, B, and B, A, and they would be considered the same thing. So how many ways can I choose these 2 games? So this is very similar to the problem where we counted the diagonals, where like the AB and BA were the same thing. So I'll give you guys some time to think about how you might do this. Albert, be quiet. My brother's trying to ask me questions and stuff, so. Albert's. Yeah, if you have to go, then yeah, bye. So I'll give a hint. So for the first, so you have 100 games, right? So then for the first game, you have 100 choices, just like with the digits. And for the second game, you have 99 digits. So normally you just multiply that, but that's for permutations. For combinations, if you choose, let's say, Minecraft, and then chose, I don't know, what's a popular game right now? I don't know, Among Us. So let's say you chose Minecraft first, and then Among Us. That would be the same thing if you chose Among Us first, and then Minecraft. So you have to keep in mind that. So it's not just this. It's actually this divided by 2. I guess, yeah. So the answer to this would be, if you did some math, you would get 4,950. We can check the slides. And I'll erase my drawings. Oh. So indeed, there are 4,950 total ways. So why we divide by 2 is because, let's say game A and game B, there are 2 ways you can switch them. Like there's 2 ways you can order them, with AB or BA. And then you have 3 games, you have ABC, then you would divide by 6, because that is how many ways you can order A, B, and C. So here, I'll go on to the next slide. Okay, so next, what if we want to choose 5 games to play instead? So like instead of 2 games from 100, we want to play 5 games. So how might you think you would do this? So I'll give a hint here. If you cared about the order, you would have 100. The next one you have 99, 98, yeah, 97, and 96. So you would multiply all of these together, right? But then you have to make up for the fact that there's no order. So you have to divide by something here. But the main question is, what is this something? So I'll give you guys a bit more time to think about that. So what you can think about this is that if you chose the games in order, you might think of as like you would play A first and then B and then C, D, and E. However, if you chose 5 games, how many like ways can you play these 5 games in order? And that would be the number you would divide by. So if you want to divide by how many ways you could order 5 games, this would just be 5 times 4 times 3 times 2 times 1, which is a fairly big number. So I have the answer planned already in the slide. So here. So the answer was 75,287,520. Yeah, that's the answer.
Did you put some commas?
I prefer no commas. So
Yeah, it's easy.
because normally when I say big numbers, I just say 75287520.
Yeah, me too.
Okay, so a general formula. So let's say you have 10,000 games and you're supposed to choose 5,000 of them. How would you solve that? So this is called M choose N and is denoted by M. So this notation M N. So the general formula then is N factorial divided by N minus N factorial. Basically, that's this 199, 98, 97, 96. Then, because you can order these you can order these in objects, it would be N factorial. So I made a mistake here. I think these two should have been switched, I think. So you can move this N minus N factorial down here. You get N factorial over this thing. So next I have, okay, so here I have 3 examples. You can think about how you might do each of these problems. So if you have an answer, you can chat it to me or Alex or somebody else. So a hint for this first problem is that for a line segment, there are 2 endpoints. And you might be able to solve the problem by like how you choose these 2 endpoints. Okay, so So it's been a bit, and I'll explain this problem. So we have a cube. I need to stop saying so. Says we're given a cube, so I'll draw a cube. Beautiful. Now, each line segment is defined by each of its vertices. So I'm gonna stop saying so. So a line segment is defined by 2 of its vertices. A cube has 8 of these vertices. Then all we have to do is just choose 2 out of these 8 vertices. And it would be 8, choose 2. Which, if you do some math, you'll get is 28. Now we'll just do this one, and we won't do the other one because there's another topic at the very end I just want to briefly talk about. So I'll give you guys like a minute or so to think about that as well. Okay, so it's been a bit. So, okay. For this problem, it says find both the number of strictly increasing and strictly decreasing 5-digit numbers. A number like 12589 is strictly increasing while 36779 is not. Something we have to notice here is that given 5 distinct digits, let's say 38754, there's exactly one way to order these such that you get a strictly increasing integer. For example, 38754 will turn into 34578. Now you've noticed this fact. If there's exactly one way to turn this into that, all we have to do is find how many ways we can choose 5 distinct digits out of 10. So if we want to choose 5 distinct digits out of 10, we would just find 10, choose 5. And let me do that. So a way you can calculate these chooses fairly quickly is by writing, let me write this down first. So first you write down the numbers of 5 factorial. Then you write down 5 numbers starting from 10, counting down by 1. And then you reduce. So like this 4 and 2 would reduce with the 8. This 5 would reduce with the 10, you leave behind the 2. 3 would reduce with the 6, you leave behind the 2. So then 2 times 9 times 7, that's 252. So our final answer for this problem would be 252. Yes, what is your question?
Isn't it 9 choose 2? Because I don't think you can use 0 because that would have to be in the beginning, but then it's not like a 5-digit number.
Oh yeah, that is right, actually. Good point. So we can't, oh yeah, that's true. So
Yeah, because like if it's 0 is the first number, then technically
Yeah.
it's 4.
yeah, my bad. So it is 9 choose 5, I think. Yep. Cool. So that'd be 9, 8, 7, 6 divided by 4, 3, 2, 1. And that'd be
What
9
about
times 7 times
if the
2,
digits repeat?
which is
Never mind.
136, 126, I think. Okay, so on to the last topic, which is called stars and bars. So how many different ways are there to place 8 identical balls into 5 different boxes, where each box must have at least a ball? So here we don't have much time, so I'll just tell you guys how to do it. So you can use this technique called stars and bars. Yeah, fair enough, Sam. I'm trying to not do it. Stars and bars. So we have this diagram here. Each of these circles represent a ball, and we put 4 bars here. So those 4 bars separate these 8 balls into 5 different parts, and you can represent each parts as a box. There's 8 balls, so there's 7 spots in between we can put our bars. There's 4 bars and 7 spots, so there are 7 choose 4, which is equal to 35 possible ways. If, let's say, we want to place 8 identical balls into 6 different boxes, then we would have 5 bars here, and we would have 7 choose 5, which is a different number. So man, I'm being really laggy today. So that's it for the lecture today, and come back at 5:35 or sometime like that. What time is it now? And
Bye.
yep, okay, so bye everybody, and see you guys in 5 minutes. Bye.
Bye.